All right, thanks for joining us. Tonight what we're looking at is our Russian English CTF, the RuCTFe, and what the misec team did. So this is our debriefing call. It's the final call in the team process. My name is Wolfgang Gorlick, of course, JW Gorlick on Twitter. I was the team captain, fortunately enough, this year. And our agenda is an overview of the process. We're going to look at our fundamental strategy and how we laid out the squads. Then we'll talk about our setup, some of the changes we noticed in the rules and how that affected our gameplay. We'll review the services that are available to us this year, and then we'll look at what really happened when we went. You know, you got the plan and you got what happened, and sometimes those are not the same thing. So we're going to look at what really happened. We'll have some of the squad leaders and people from the squads jump in, and then we will touch on lessons learned and some planning for next year's event. With that, the Russian English CTF and how it works. There's a few different ways to score points. The three main ways are maintaining service levels, so your uptime. These are defensive points, and you get 1 point per service per time the scoreboard checks. So you get your uptime points. Another way to achieve points, and this is pretty novel, and actually one of the things I really like about the Russian CTF, although it wasn't in place this year, as we'll discuss. The other way is by writing patches. So you find vulnerabilities in your web service, you issue an advisory just as if you were a traditional white hat hacker who had found something and you want to issue it to the developers. You write a patch and you send that in, and that can be worth quite a lot of points. And then finally, as in any traditional capture the flag event, you have attack points by capturing the flags from the competing teams. And what a flag looks like in the RuCTFe is it's a 32-character string, alphanumeric, ending in an equal sign. Some of the things that are against the rules are filtering out other teams' traffic, so you can't put up a rule to block a certain team or to prevent them. You can't generate a large amount of traffic that threatens their network. You're not allowed to attack the teams outside the VPN. So in other words, if you know where they're hosted, you can't go after their infrastructure gear, etc. And you're obviously not allowed to attack the infrastructure facilities that are operated by the organizers. Now returning to this top one, filter out other teams' traffic. That is specifically on the TCP/IP layer. So you can't block a TCP port, you can't block a UDP port, and you can't block out, of course, the IP traffic. You can do some interesting things, right? So you can, for example, do an application layer. If you notice someone's going to do a SQL injection attack in a service, you could set up a filter, for example, that would drop anyone who was doing OR 1 = 1. There was also some talk by the organizers this year that it would be within the rules to prevent a flag from leaving. Now, we didn't implement either one of these this year, but it's definitely something we want to investigate next year. So, for example, we could use that regex pattern, know what a flag looks like. If we see someone stealing flags, perhaps we put something in place to stop that flag from going out over the network. The organization of the game is into three main rounds. The first round is really getting off the ground. So you, at the hour 0 of the contest, you get the decryption key, you decrypt a vuln, which is your vulnerable server that has your flags. You mount a vuln onto a hypervisor, give it an IP address, change the password, those basic things. You start doing some basic hardening, and you get ready for the event. That first hour is really critical because you want to have a good, strong start. If you look at some of the visualizations from past years, you notice the minute it gets to round 1 of the competition, the traffic just goes flying. This year, one of the changes in rules was having 2 rounds. So round 1 was everyone getting broken up into 3 groups. Those 3 groups had 50 teams per group. And those 50 teams could only see each other's traffic, beat each other up, and then at the end of round 1, which was 3 hours, at the end of those 3 hours, the top 10 teams from each one of those groups went on to the top heat to compete for the top 30 slots in the competition. And everyone else went into the second heat to complete for the remaining teams. This picture is from the organizer's network diagram, and you can see the basic setup of the infrastructure. Every team is on a 1023 network, 1023 with your team number. Our team number this year was 22, so our network is on 1023.22. That's /24, or if you're kicking it old school, a Class C network with 255 hosts. Those are connected via an open VPN to the main router. The main router connects you to the teams in your heat. And you have an organizer's network. Organizer was on 1023.201. And the organizers is where the scoring system lies, it's where your flag submission lies, etc. So you don't necessarily need to do a lot of enumeration. You know pretty simply by knowing the team's number where their flags are. They're always going to be a 1023, the team number .3. This is a scoreboard this year, and we'll dig into this more in a bit, but just to highlight a couple things about this is, one, you've got each service listed in its state, up, down, or mumble. Up means it's fully available on the TCP UDP layer, as well as the application services functioning properly, meaning the scoring system can submit flags and read the flags. Down means it's completely down, scoring system can't talk to it, and TCP UDP is not working. And mumble means something in between. So in other words, some parts of it are working, but some parts aren't. New with the scoreboard is if you hover over the status, it would pop up the error message. So 404 or can't log in or whatever. That was pretty handy. Likewise, if you hovered over the team number, it would give you their IP address. The defense points is 1 point per service per time the scoreboard checked. Scoreboard on average checks 5 minutes, but that's variable. You can't really predict it. And the attack is 1 point per flag captured from each one of these services. This rating, if you see attack over here is 100%, is on a curve where the highest team for attack is 100%, the highest team for defense has 100%, and everyone else is rated down. With that, that gets us to the strategy in squads. What we did this year, as opposed to our 2011, is we really focused people in on areas that they had an interest in and a skill set in to make the CTF a little bit more approachable. So instead of somebody having to cross-train in all the areas, we let them focus themselves in on where they felt the most comfortable or the most interested, and therefore it shrunk down the amount of preparation they needed to do to be ready and to be effective. So we had people focused on code, we had people focused on operations, we were doing full packet capture on key ports, we're utilizing an IDS for key identification, so we knew both when the scoring system submitted keys as well as when other teams stole keys. We had some honeypots just for the fun of it, and we'll cover that a little bit later. And we're also doing IP tables, basic firewalling to protect our team members. The team structure was broken up into 4 squads. First squad was Dev, and on Dev was Charles Green, Trevor Bammel, Rashad Williams, otherwise known as Yet313, and Jack Wink. And what Dev was responsible for was looking at the source code, running analysis tools, static analysis tools like RIPS for PHP, like Brakeman for Ruby. In some cases, reversing the code. We had a .NET service that was reversed with .peak. There's some Java services that could have been reversed. So going through that code, finding weaknesses, as well as once the weaknesses were identified, preparing those advisories to submit them for those, buku high points. And again, the advisories, the score for advisory depends on the complexity of the vulnerability, how hard it was to find, its presence of exploits. It says here it can't exceed 10 points, but last year in 2011, 17 advisories equaled like 1,000 attack points. So this was something we really wanted to get this year. Advisories were focused on heavily. Another thing about advisories too is it doesn't have to lead to a flag. So advisory could be cross-site scripting or any number of things. It does not necessarily have to lead to attack points. And once the dev team analyzed the code, their job was to put it in Dratus and convey that information to the red team for attacks. Op Squad, as I mentioned earlier, Op Squad, or you get a lot of points for defense. So we really wanted to make sure we were hardened, we were up, we're operational. Op Squad featured Chris Jenks, otherwise known as Radis. He was the squad leader. Mark Kikta, which is 357 Tech. Zach Zeed of .hack, and Stephen Iao, NASQUAM. Should mention that Zach Zeed and Stephen Iao were also our hosts for the facilities. Main key things about Op Squad is keeping those services running so we get those defensive points. Hardening the OS. In 2011, there was a code execution flaw that actually allowed attackers to remote into our systems and wipe out all the files. So we wanted to make sure we were hardened and prepared. In 2011, patches were released mid-contest, and so ops would also be responsible for applying those patches when they were released and doing host-based forensics, looking at the memory, looking at the file system for the presence of flags. As I mentioned earlier, you get 1 defense score for integrity availability of each service. Each time the score system checks it, and that's variable, anywhere from a couple minutes to 10 minutes. On average, it's 5. With the host-based forensics, the key thing is finding where the flags are, figuring out how to weaponize and get them out, and getting that information to red team. And when we get to the stories, I'll illustrate one of the cool things that .hack did, where he was actually able to, by looking at the host and working with Mark, figure out a way to yank out a whole bunch of flags. Yeah, as I mentioned, the opposing team whacked our server, so we wanted to be hardened and not be down. Blue Squad, this is the traditional blue team function, right? So if you're familiar with the concept of blue team, their job is defense primarily on the network layer. So our blue team was huge. We had Derek Thomas, DTOM, as squad leader. We had Keith Dixon, otherwise known as Taz Drummer. Matt Johnson, the blue kid himself, MWJ Computing. Stephen Legg, Zen Mode, who was responsible for much of our network setup. David Marcus. Craig Maxfield, CDA is Cool, who also worked very closely with Zen Mode and .hack to get us all set up. Jeremy Nielsen, Conrad Voits, and Scott Sakuto-san. And this is a quote from Jeremy Nielsen. Was it just me, or did the blue team outnumber all the other teams combined? We had a lot of people in blue. We really did. I think that's because misec in general is comprised of IT people who play blue team in their daily jobs. It's where a lot of us are comfortable. And as I mentioned earlier, our goal with this misec, our goal with every CTF, is to create a learning environment, right? And so our goal with the organizations this year was that people, when they wanted to learn, or people, when they wanted to play to their strengths, had the ability to do that. And I think a lot of people really felt comfortable jumping in on blue. Blue works from the IDS. They do network forensics. They do traffic review. Their whole goal is to see what flags are being stolen and where flags are being deposited, and get that information to the red team. Figure out what's going on so we can weaponize it. And this is a screenshot that Jeremy provided that shows the security onion and squill, how we're pulling out as much information as possible. Also note here it's 10.23.22.3, that's our vuln, to 10.23.201.11. I'll circle back to that later on and talk about how we're kind of thrown for a loop when we started seeing a lot of traffic from 10.23.201. Lastly, red squad, the traditional red team, the attackers, right? So if ops is responsible for getting us points through uptime, red is responsible for getting us points through ensuring that we're getting flags, we're doing some cool stuff. On the red team, we had Josh Little, Z Tango. He was a squad leader. Mark Lenigan, Nightshade. We had Nikki. Unfortunately, he was unable to make it the day of. Nicole, also known as Rogue Clown. Aaron Pohl, also known as Adonis. And Mark Stanislav. And Mark, too, unfortunately, was not able to make it the day of. The whole purpose of the red team is to attack, attack, attack. Look at the notes and DRADIS from Dev, Ops, and Blue. Weaponize existing attacks, develop new attacks, and send those to Dev and Ops so we can harden and capture and submit those flags. So that, in a nutshell, was our strategy. Have Dev working off their own copy of Vuln. Oh, this is another thing. We had everyone with their own copy of Vuln. So Dev would get a copy right off the bat. Ops was going to be the only one to work with a live copy Hey, Don, give me a second, okay?
Oh, sure. Take your time. Sorry, I know I'm wasn't sure if you guys were just running over the same thing.
Not a problem. So we had Dev. Ops was the only one who was going to be allowed on the live one, just to make sure that there was, nothing happening that would take things down. Blue was working off the secure live onion, secure onion, and Red was working from their own notebooks in attack posture. So in general, our strategy was simple, focus, be a fast follower. Other people are developing attacks. We want to follow them very, very quickly. With that, we'll get to our setup. All right, so let's dig into this. Again, the layout of the RuCTF has an organizer and a 10.23.201 network. They've got a port that listens for flags. They've got a scoring system that logs into your vulnerable box to deposit flags, as well as to read flags out. The full cycle, connecting, depositing, reading, is what constitutes a service being up. Any break in any part of that cycle constitutes a service being mumbling. And the IP addresses are 10.23 N, where N is your team number. All the vulnerable boxes end in .3. So the way we had our network configured was we had a physical VPN server running untangled on 10.23.2.1. It was a physical box that connected to the VPN arena. We had the Vuln server, which is running booking, bluster, flight process, etc., which we'll cover here in a little bit. That was on 10.23.3. We had test, and test is simply there to confirm that UDP and TCP services are working over the VPN. That was on .4. These two were VPNs. I'm sorry, virtual machines. And those virtual machines were running on a hypervisor, which was 10.23.22.5. One of the things that we learned was, hey, make sure that hypervisor is behind a firewall, behind IP filters is blocking that off. So a lot of people trying to attack that, which was interesting. We had a team server that was a VM running on my notebook. The team server had IRC for chat, Git for source code, which we ended up not using because the team server seemed to be going pretty sluggish. We opted not to use Git. And we had DRADIS for communicating notes and keep track of what's going on.
Hey, Mark, sorry about work.
Hey, how's it going? We had, huh? You're at home? You made it home? Good deal. So we had a blue server, which was running Security Onion, that was on physical hardware. We had an ops server that was a VM, and that ops server had Nagios, Syslog, and Snoopy. And then we had the honeypots. And Taz, did you want to jump in here? I didn't have a list of everything you were running for honeypots.
Okay. Well, I had about 4 or 5 set up, but decided to go with the updated HoneyD, which you can pretty much emulate any operating system out there if it's got an Nmap fingerprint. And I went with Amun, which Amun seems to be a dirty, dirty little tramp of opening up many, many ports, so I figured that'd be a good target. And for the HoneyD, I'd set up 3 in the config file, which seemed to kind of make sense at the time. Windows XP Service Pack 2 and Service Pack 3, and just to kind of throw a little wild one in, I found a iOS 4.2. So yeah, when they were doing a scan, all of a sudden they'd see iOS 4.2. What the heck? And it was just for giggle's sake.
Nice. And you had a couple people scanning and beating on those too, right?
Oh yeah. Toward the last hour that I was there, all of a sudden the 3 HoneyD ones just really started lighting up. It's almost like someone was doing a full, complete Nmap scan. And I tested this before I came. Since I found the updated version, if you did a Nmap -A, it will give you the operating system that you tell it. So if you give it the fingerprint of make this a XP Service Pack 2, it will return XP Service Pack 2.
Nice. Very cool.
So we could use that to next year to kind of obfuscate anyone trying to do an OS fingerprinting of the Vuln server?
Yeah, and my idea for next year was maybe set up 5 or 6 to emulate the vulnerable server to make it look like we even have other virtual machines on the network. Let them get tied up trying to attack those while the main one is still going, and anyone who's doing any kind of work against the vulnerable, a copy of the vulnerable server, they're doing it kind of offline, if that makes sense.
Definitely. Good deal. On the hardware side, we had a Cisco port that CDS Cool provided us, 48-port switch, USB drive, 2 terabyte, which ended up being way overkill. What did we get, Derek, Scott, for PCAPs? Wasn't it like 2 gig or something less?
It was less. It was only about half a gig total, due to a couple of issues we had initially.
So we could probably get away with maybe a 100 gig drive or a 40 gig drive even next year as opposed to a couple terabytes?
Well, it's about 500. Theoretically, yeah. I mean, we were only capturing traffic coming from the VPN to the Vuln server, and basically anything that was on that port. So we were also getting traffic for the .4 and .5 addresses. But if we were to open it up, we'd see a lot more traffic, but with the limited scope we had, yeah, we didn't see a whole lot.
Makes sense. And Scott, you had provided the Security Onion hardware too, right? And then we had the hypervisor, which was a IBM server, 4 CPU, 16 gig via Zen mode, and we had some server hardware by Radis for Untangled. Online Tech graciously sponsored us. They had us back, which was a good sign. I guess we were good to them. So they were very good to us, and we were back in that war room like we were last year, which was a very good thing. the way we had the seating is we had the ops squad table over here, and then we had the red team along the front facing the scoreboard. We basically had the developers this way. Jeremy on blue was over here, and we had blue this way with another couple developers. Of course, we have the Red Bull. Thank you, Scott. That's like critical when you have servers, ops guys. Gotta get the Red Bull. You can see Mark up here doing his ops thing, making everything work. As I mentioned, we had the dev this way. And the scoreboard's up front. I'm getting echo from whoever just joined.
That's me.
I'm going to mute you, okay?
Okay.
Thanks, man. Just put it in the chat window if you have something, jump in and I'll unmute you. The timeline originally was planned from 9 to 7. We ended up, due to some overruns the day before, we ended up coming in, a few of us coming in at 8 o'clock to get some equipment staged and set up and confirmed. And then 9 o'clock, most people came in, plugged everything in. 10 o'clock, we decrypted the vuln image. We'd initially planned on the ops side to spend a good chunk of time hardening that image between 10, 11, 12. But a lot of that time got chewed up because we're having issues with the scoreboard and score system talking with us. So we're spending a lot of time troubleshooting and seeing how that was going. Because of those issues, the organizers actually extended the competition an hour and a half. So instead of ending at 7, we went to 8:30. And of course, we had dinner and whatnot at the Olive Garden. Some rule changes this year. There was really 4 main ones. The advisories, which I was personally very excited about because I thought we could gain a lot of points, especially since we had Charles Green and Jack Wink and some strong developer talent. Changed. There was some natting, which I talk about. Attacks were based on defense, and of course the rounds. So the advisories, yes, the night of, right before the event, the organizers opted to drop the advisors this year. So there were no advisory points. I'm really hoping, and the RuCTFe guys, if you listen to this, hear our heartfelt plea, that I'm really hoping that they'll bring the advisories back next year, because those are a cool way to earn points and a good way to get developers involved. But yeah, that really put a crimp in our dev squad plans. Number 2 was, hey guys, why is the scoring system attacking us? I think that was Craig who said that. We noticed this year that all the attackers were natted through 10, 23, 210. So at one point in time with our blue team, we're looking at, okay, we want to watch these 3 teams, so we'll set up the filters to watch these 3 teams. And of course, we couldn't differentiate between who was attacking. And it also took us a little bit of time to figure that out. Derek was taunting people, trying to get them to attack us, and we couldn't figure out why the organizers were suddenly sending us more traffic. But yeah, netted.
I think there was also
and then,
caveat to that. Sorry.
Yes, go ahead. Shoot.
And that was only when they were going after the flags or something along those lines. Because there were times when they were getting attacked. I remember when someone was doing a brute force SSH attack against us. They were
yes.
That was coming directly from their IP address.
That is absolutely true. So yeah, it seemed to be only when they're going after our web services. Although also too, we noticed that when they're scanning the honeypot, they're coming through this network. So it seemed very inconsistent.
I wonder if there was a filter or something on there that if it included that regex string, that it natted that when that regex string was included in whatever the traffic was.
That might be.
Or possibly just our vulnerable ports.
Okay.
If it was just the vulnerable ports, I believe that, because that makes sense. That makes the most sense. But it doesn't explain why we saw the, well, wait, no, it does explain. You're right. Because, Taz, you mentioned that the organizers kept hitting those servers on port 80, right? Your honeypots on port 80? So if it was on port 80, that was one of the service ports. So, yeah, that was probably it.
It's throwing it out there.
Number 3, a quote from Zombie Tango that actually I woke up in the middle of the night hearing this. No,
The bane
I
of
wasn't
my
in the middle of the night.
existence.
Yeah, booking's down again. I got flags. It wasn't, I didn't wake up in this. I tell you this, I got home. By the time I got home and everything and started chilling, it was like 2 o'clock in the morning. And I was on IRC. And someone went, Wolf, booking's down again. And I jumped and I checked the scoreboard. I'm like, what? Fix it. I'm like, damn you guys. Like trained. But yeah, so number 3, and this was pretty novel, and I really like this change. The flag submission service rejected flags if your corresponding service was offline. So if Zombie Tango had a booking flag, he couldn't submit it if booking was down, which was
Booking
really
was
good because
always down.
ops was critical. Yeah, well, no, we had it up.
We actually did like 20 minutes at one time.
Yeah. Yeah, so, and again, this is not necessarily for the people who are on this call, but for our next year's team when we review this video, the big challenge with ops is figuring out why the services stop. And we never did figure out why booking would not run. We did figure out why MCH was having a problem, which we'll get to, but that's really the big challenge with ops is keeping the services up, figuring out why they're breaking, because they're deliberately installed in such a way that they crash. Number 4 was this concept of 2 different rounds. The first 3 hours being groups of 50, and the scoreboard was reset, and then the remaining time being 2 groups, one with the top 10 and the rest of the bottom. Which is good in theory, but as I mentioned at the top of the call, from 10 a.m. to 12:30, which was a good half of the round 1, the scoring system couldn't see us. The flag submission would work for a while and then time out if you had a ping to it. Things are going up and down, up and down. So unfortunately, we really suffered this year because of this. But I think if the VPN was stable, it's probably a good rule to have in place. With that, we'll do services overview, and then we'll jump into some story time and then hit lessons learned. So the services, one of them was MCH. MCH was on TCP port 8080. It was a compiled Java applet with a Mongo database. How to attack it, we have no flipping clue because we got no flags on it. But it had this little interface where you would put in your name, some private data, and go with it. And when we get to the ops, Mark, we want to hear from you about how you figured out how to get this thing to run, because I know that was an ongoing struggle, and we're one of the few teams who were able to get it up. Lust, which was a luggage manager service, it ran on port 1437. It's actually written in mono.net, which was cool. We were able to decompile it with .peak, which was awesome. It had a HTTP listener, so it effectively implemented a web service within the code, which was pretty interesting. And what it was susceptible to was URL injection. So you could append, the classic OR 1 = 1 and get out all the keys. Charles Green was beaten up on this. He got pretty close, but we never could get to the point where we weaponized it, so we didn't get any flags on it. GeoTracker, also a Java app. It was on 2 different points, 1900, 1901. It actually had a parameter validation flaw that we were able to exploit quite a bit and get 416 point flags on round 2. GDS, which was a compiled C app with a Qt backend, which was listing on port 2012. This actually connect for flags. You get some information out, and with the information you got out, you could submit to the booking service.
For that one, there was also, oh, sorry.
Go.
In the config file, we noticed that the both the username and password were listed in plain text, booking. So if the team didn't change that, or you could log into their database, grab all the flags out of there, and then change that password.
Nice. And that was when was it towards the end of the afternoon we were going through and resetting everyone's password to misec was here?
Yeah, that was like the last 20 minutes. When I couldn't submit any more flags because we couldn't get, after we changed our password, and we couldn't get booking back up. That was how I spent my last 20 minutes.
misec was here. Next.
Don't use special characters in telnet-based password prompts.
Yes, and don't backspace either.
Good points. Flybook was on port 80. Flybook was written in PHP, so they were analyzing it with RIPs. Ran on the Apache. And the issue with Flybook is you could get access to DB sessions to extract all the sessions and pull the flags out. We got 1 flag in round 1, 48 flags in round 2. And I believe we had patched that by updating our Apache conf to block that file, right?
Oop, there we go. Now I'm on mute. The problem was with them all coming from the organizer network, regardless of whether or not they were an attacker or the organizer, our patch did something. I mean, it kept the service up because originally the default was deny from all, which essentially meant that it was down for the organizers. But our patch didn't do as much as we thought it did because of the fact that it wasn't really blocking the other teams as they were all coming in source natted from the organizers network.
Right. So we had a strategy, but we'll have to tune it a bit next time. Flight process, this was another one we couldn't really dig into, so we don't know what the attack vector was. It was a Python app with Django, 10-800, just popped up, hey, not logged in, sign up with the administrator. There was a bypass where you could sign up with the administrator using a cookie value, but we couldn't figure out necessarily how to get those flags out of it. Buster, which we didn't solve in time, but there is a pretty good write-up on it. Buster was a Java app back-ended on SQLite. This on port TCP 2885. And the problem with Buster was those weak crypto. So I implemented triple DES in CBC mode. And by analyzing the crypto and feeding it some values, you could actually get the flags out of it. Booking was compiled in 8000 and never stayed up for some reason. Used GDS for the back end. And we got 0 flags in round 1, 26 flags in round 2. So what actually happened, we had the plans, we had the squads, people were focused, we're going to harden, we're going to share Git, everything was going to be great, you know, roses and daisies. But as Derek would say, hey, good plan, bro, needs more dragons. And as my shirt had on it, you know, no plan survives contact with the enemy. We had some difficulties. In round 1, we came in 26th place. And as I mentioned, a lot of that had to do with connectivity issues. Those connectivity issues chewed up Ops' time, which meant we really didn't have the ability to harden the OS like we had wanted to, which ended up not being as bad of an issue this year. Last year there was the remote code execution. People came in, they wiped our server. This year there wasn't any vulns that had remote code execution, so not necessarily as big of a deal, but definitely not to plan. By round 2, everything really seemed to come together after lunch, like around 2, 3 o'clock. We really started humming together well as a team. Came in 22nd out of a couple hundred or 116. And so if you look at it last year, we were in 32nd place, or 32%. And this year our overall was 52nd place, so roughly comparable, with not a good showing in round 1, but a pretty good showing in round 2. With that, I'm going to turn it over to squad leaders. Derek, you want to tell us a bit about what happened in blue and what you saw and what you think we could do better?
Yeah, definitely. So last year, I remember we had the team going, and one of the biggest issues, well, a big issue that I thought we had was we didn't have any visibility in the network. So I remember thinking, I'm sitting there, and we're trying to find the flags, and I'm thinking, if we could just read the packets, we could see what everyone else is stealing our flags. So that was one of the big pushes I thought we needed this year. So we decided, well, first at DerbyCon, I saw the presentation by Doug Burks, and where he showed how easy it was to implement security on it. And I'm like, we have to do that. That's everything we need. So we started kind of experimenting with security onion setup to see if it worked well for us, and it seemed to come together pretty well. Everybody from the blue team kind of contributed a little bit. They set it up at their houses. And the idea was to full packet capture to our server so we could check and filter up the info to vulnerable services and really see how our flags are getting stolen. But, you know, we thought maybe that's a lot of data. So we were thinking about creating snort rules because I figured it would be pretty easy to write a snort rule based on the regular expression the organizers gave us to determine if our flags were indeed flags. So Jeremy was able to write that up, and it was pretty sweet. None of us had really worked with Security Onion. We had a lot of good exposure to network security monitoring, IDS, and kind of a chaotic environment. But we got up and running, and you know, at first it was kind of slow. We were starting to get our bearings, but I think we were able to really leverage that and feed intel to the red team. So we were really just trying to see how our flags were getting stolen and kind of relay that to the red team so they can reverse that information and kind of weaponize it, start stealing from the other team. So it took us a while, and if we knew, we were waiting for people to attack our flags, and we were just sitting there waiting and waiting, and we're like, no one's taking our flags. What, are they scared of us? No. But finally we realized that everybody was being netted. So I remember thinking that earlier too, and just kind of disregarding that thought. So next year I'm going to trust my gun a little bit more. I ended up having a little bit of hardware issues.
I don't know if this helps, but on the Untangle server, if we decide to use it next year, I know it has integrated IDS. What we can do is we can turn off the blocking and just leave the logging up. So then you can set your own rules, or you can use the predefined ones, and it uses snort on the back end.
Yeah. So I mean, yeah, totally. We're definitely going to take a look at the architecture, see if we can improve it. A lot of people had some issues connecting to it, so another big push is for everybody to maybe we'll have better directions and make sure that everybody has connected maybe to a sample server, so we know we're up and we're good and we can connect. So yeah, that would be a good idea with the IDS. So overall, I think it helped out a lot, and we were really getting great visibility into just the attacks that are being performed on us. So I think hopefully next year we can leverage it even more and weaponize more exploits. So does anybody else have any thoughts of the blue team? I thought overall it went pretty well.
I'll just say that on red, we would not have had the flags that we got without blue team. I mean, pretty much 2 of the 3 services we were getting flags directly off of intel from blue team and from Jeremy. So way to go, guys, for that one. That was awesome.
Yeah, that was a lot. Yeah, that was a lot of Jeremy's doing too. I think another thing is the seeding, because we were kind of blue team. We could have better strategic seeding and communication. It would help as well.
I got to say about blue team, you know, it was great. You know, when they first started attacking, you know, we were able to we were more or less able to mitigate the risk almost immediately. You know, you have maybe 3 attacks coming down, we can mitigate that and prevent that from happening, or prevent the host machine from getting popped, which was a big thing. So I mean, thanks guys.
Yeah, definitely. And one thing I like too is I felt like it was pretty much an enterprise level solution, and it kind of gave people exposure to skills that can be used in the real world. I mean, I don't think it does not get any more chaotic, and you don't get that high level of hackers attacking your servers ever. Hundreds of teams of hackers trying to take you down. So I don't think it gets any better than that.
Yeah, that's a good point. It's excellent training for the real world, right? And hopefully you're never in a position where you got hundreds of teams of hackers trying to take you down at the same time. But if you are, at least you know what to do.
I'm calling misec.
Anything else on blue before we switch to red?
I'm all set.
All right, so that was Derek Thomas, blue squad leader. Red squad leader was Josh Little, otherwise known as Zombie Tango. So Josh, what do you got for us on the red squad?
Just a couple things. So pretty much, red, we were a little short-handed this time, which is fine. Aaron and I did what we could. And again, like I said, we would not really have been able to do a lot of what we did without blue team. So I think that was a really, really nice addition this year to our arsenal. And I'm going to echo what Derek said about seeding, and I kind of sent this to him offline. I think that may be our next strategic point next year, is to get each of the teams kind of situated in an organized fashion and kind of line them up so that, I think the way I had it set up was like, red was going to sit between dev and blue was going to sit between red and ops. So essentially the ability to just kind of spin one way or the other to find your other comparable or compatriot group. Blue kind of spans that group between ops and attack, and dev helps out attack, and same with blue helping out attack. So I think we kind of organize it. So I don't think we would have done, Aaron and I would have done as well if we hadn't been sitting kind of right next to each other as well. It really allowed us to take a look at exactly what each of us was looking at, what we were working on, and kind of share ideas directly. So I think that was kind of something that we may want to look at next year. As you kind of went over the services that we were attacking, 2 of the 3, again, like I said, we pulled it directly from Jeremy. So the DB sessions file, he pretty much saw that coming through and said, hey, it looks like there's flags popping up from here. We pulled it up. We're like, hey, look, there's flags. Trying to automate some of that stuff. That was one thing that being a little short-handed and everything being a little chaotic, we didn't get really a good chance to work on. One of my plans originally was to have someone dedicated to working on automating all findings to the scoring server, and that kind of, I know Conrad got something working towards the very end of things, but that was one of my plans to get as right off the bat, but with kind of I think a little bit of the rush what's going on at the beginning, and being shorthanded, that didn't come out as well as I wanted it to. So I think that's something that we're going to want to work on next year, is at least have some kind of a framework set up that we can use and modify just slightly to get working. So this is now 2 years where the scoring server has just been kind of a simple socket-based log in, throw your flags in there, log out kind of system. So I think just getting some kind of a framework script that'll take flags and immediately submit them to that kind of a system is something we should have done before next year. I think the only one that we really were getting out based upon code review and or actually us figuring out what the hell was going on with the system was the booking GDS piece. That was an application that was written in D, meaning GDS. So GDS was written in D. The source code was available. And you could kind of read through it and reverse engineer the actual protocol itself. I'll tip Zach for that one with those guys on ops coming up with that booking 2012 config file. That's what kind of led me down the path of looking through that source, finding out where that thing was being called, and then that's where we found the API stuff and kind of figured it out from there. I think with that application, what was actually causing some of the issues was it appeared to have some kind of a caching mechanism that as we were going through and attempting to attack the flags themselves, it had just a URL with a simple get parameter that was the reservation ID of the flight name. That was what we were pulling out of the GDS application, was all those registration numbers. But you couldn't, for most systems, just directly add that as a get parameter. It seemed like regardless of which reservation ID you put into some of the systems, if you didn't fully go through the path of the application itself, it was returning back the same page every single time. And that was regardless of what the browser caching settings were. So it appeared to me, at least, that there was some kind of a write-out of a cache file on the server itself, and that may have been what was causing us to have the thing go up and down, is that they weren't getting the flags they were expecting for that reservation number, and they were marking it kind of as mumble or down or whatever they were calling it. Because there was some systems that were out there that did not show that issue. So for those systems, you could actually go through and automate pulling the flag just by doing simple wgets or just gets against that that URL with the new parameter in place. But for most systems, it wasn't. So that's kind of how I read that. We'd have to go back through the source code and find out how that was working, whether or not that was the case. But I think that's about all I have. Aaron, do you have anything to add?
No, not really. I think you covered it pretty well.
Okay. All right. Anybody have any questions about Red?
I have something.
Sure. Shoot.
This is Wolf. One of the, so these are all web services.
Mm-hmm.
And I happen to know that you happen to know something about OWASP Detroit.
I kind of do, yeah.
It would be very interesting, I think, if we could reach out to more OWASP people, and perhaps even with the new year coming, maybe take the Vuln server as it stands at the end of the day and have an OWASP talk on, look, here's how to enumerate these, here's how to look at them from web application vulnerabilities, and start leveraging the OWASP community.
I think that's a fine idea.
Oh, we're getting lots of feedback again. Pardon me while I mute people till I figure out where the feedback is coming. So that was one of the things that I was thinking about, was more involvement with OWASP. And then the other thing I wanted just to circle back on and point out is we talked about the importance of ops doing host-based forensics. And yeah, I remember just .hack last year, Zach was popping boxes with Armitage, and this year he was just ecstatic when he was able to go through with you and 357 Tech and do the host-based forensics, find those files, write that bash script that could execute it. So for the ops people for next year who may be listening to this call, that's definitely one of the things to point out and to dig into is what's going on in the file system and how can we leverage that for what we need to do.
Yep, definitely.
With that, 357, are you on the call with us?
Yep.
All right, I'm going to kick it over to you, Mark, 357 Tech, who was not Ops Squad leader, but who was on the Ops Squad and has some good things to tell us. And also, you know, one of the moments I remember thinking back that I thought was just really exciting was you had Larry, who had a spectator ticket, Stephen and Hack, and you guys were on, and I just remember you kept saying, I'm going to get MCH if it kills me. I'm going to get it if it kills me. And that time when you finally got it, and like the whole room went crazy, that was amazing. That was very, very cool.
So the whole thing with MCH, oh, sorry.
Go.
The whole thing with MCH boiled down to, it was running that MongoDB in the back end, and we couldn't figure out what was going on. We kept trying to run it manually. We ran a couple find commands, one-liners, ran through, and eventually found it. You know, it was 20 or so directories deep into the file system, and so it ended up just being that we found it, started trying to run it, but it's trying to connect to a database over some random port, and we couldn't figure out why it wasn't connecting. So about 2 hours down the road, I started trying to just manually call MongoDB, which wasn't a valid command, but it said we might want to install the Mongo server, and which would say anyway, but I just tried to install it anyway. It turns out that MongoDB server wasn't installed. So for next year, one of the big things that we're going to want to do is, I know apt-get doesn't automatically do dependencies, but if we have an apps2-based system next year, big thing we might want to do is to, off the bat, install aptitude, and then try and resolve all the dependencies and update as much as possible right off the bat, because that it didn't even have the right packages installed. Other than that, you know, mostly it went fairly smoothly. Well, more or less. We didn't have a lot of time to delve into why things were going up and down. You know, we were focusing most of our time on getting MCH up and making sure everything was up and running. The kind of hack that we put together to keep everything when something went down was basically just reboot the service. Well, a lot of everything was, you know, Java, Java-based. So, you know, we could just go in and kill the process, and there were init scripts for each one of the services, except for, I believe it was Flybook running on port 8, if I'm not mistaken. And for that one, we just went ahead and rebooted Apache. Other than that, you know, big thing for next year is to keep an eye out on the file system. You know, make sure, you know, make a note of where everything is, and if you come across flags, inform both blue team and red team immediately. The blue team so they can, you know, watch for that port, and red team so they can find a way to exploit it.
And Mark, you had an idea too about how to implement or basically replicate the scoring system, right? So this time we were using monitoring that could tell us if the ports were up. And I think you had an idea too about how to check if the service was running.
Yeah, there was a, we have two options. One is, what we can do is, because this year all we had, basically we were just doing a basic HTTP command. It did a basic get return, and if it returned like 200, it just came back okay. But for a lot of them, they weren't coming back okay because they were non-standard services, custom apps. So we can either, or do both of these, look at the traffic logs and see exactly, and try and find out from the traffic logs exactly what they were checking, you know, what they were pulling down to check. Or we could write custom custom checks and have those execute through NRPE, which is the Nagios Remote Execution Nagios Remote Protocol Executor, or Program Executor, something like that. Basically what it does is it connects over port 5666. We can lock that down so it only accepts it from the Nagios server. And the traffic, and then we can run the check that way. I personally like looking over the traffic, because what I was noticing is that even though the scoring system said we were down, we could get it locally. So and the processes were running. So I would trust, you know, more along the lines of what they were checking for, rather than just checking for processes running or some other fancy program we could write or script.
Yeah, it makes sense, especially if we can. It's similar to what we did with the network, right? If we got better visibility into the network, we're able to do a lot more. If we got better visibility into those services, we can do a lot more. And I think sometimes the scoring system may say we're mumbled, we would restart it or do something drastic when perhaps it was just the scoring system hiccup that time.
Right, and that'd be a good thing to keep an eye on too. We can figure out exactly what get requested to pulling down. It might be something that we have to do on the spot, while the game's going on. But if we know how, if we know where it's coming from, and we know what to look for, it'd be fairly simple to replicate, something after the fact. After we, know what to look for.
Makes sense. Anything else on ops?
There was one issue at the beginning. I know Radis was a little missed about it. At the beginning, not having everyone jump in all at once, waiting until we get everything locked down and hardened before creating user accounts.
Right. Right, and that's actually something I touched on at the lessons learned. I know we had talked about a couple of different ideas about perhaps setting up an rsync image or some other way to get people access.
Oh, there was one other thing. With Untangle, if we use that next year, what we might be able to do is that before we harden, we could probably put hardening in the background and then only allow access to the ports that are vulnerable. So we get our initial MS in and then lock down all the other ports. So that way hardening more or less becomes a back burner to getting a good knowledge of how everything runs. And then if we need to harden later on down the line, we can take care of that.
Yeah, that makes a lot of sense for two reasons. One is the defensive points. We lose more defensive points if we don't understand how it works and how to keep it running than if someone just takes us offline. And two, last year when we got erased, what we simply did was restore to a snapshot, and we're back in business pretty quickly. So we can always quickly recover as opposed to doing prevention.
Right.
I'd buy that, absolutely. All right, well, open mic. I got open mic here and open mic and lessons learned. Does anyone else have a story they want to share? I know Nikki and Nightshade, Roclown and Nightshade, Nikki and Mark, you guys were red team, but you came in like a second shift. Anything that you guys wanted to add or anyone want to jump in?
I don't know. I didn't have anything in particular. Although I think the one thing for next year, other than wanting to be there a little earlier so I could jump into the action, just one thing I noticed was I think next year we could possibly use IRC and Dradis. I don't know if it's a little more or a little more efficiently, because I mean I know communication is always going to be a little goofy, but I don't know. I just think that some of the things that the Dradis notes were fairly easy to follow. Some of them were not. And if there is a second shift next year, if there are people coming in midway through, I guess if people took clearer notes or gave a little more context about what they're putting in Dradis, that would help people to jump in and kind of catch themselves up without having to harass other people who are obviously working on other things.
Yeah, I would like to just kind of underline something there. What I noticed when I was using Dradis was it wasn't clear to me which of the items in Dradis were outstanding issues to work on or had already been implemented, like for Red Team. So there was a lot of information in there, but like in one case, I believe it was the Telnet hack that Conrad had automated, which was what that was still in Dradis and it still looked like it needed to be worked on even after he had worked on it. Just as an example.
That's a very good point.
Completely agreed. Status updates would have been awesome.
Yeah, and some of what you were seeing also, I think, and we didn't do a good job of separating documentation of hacks from general notes. Like we were throwing a lot of stuff back and forth. Jeremy would throw some raw packet captures in there, and I definitely without the context of having been there, and while that was getting dropped in there, I can definitely see how that really didn't mean anything to you, and at the worst, kind of just get confused and muddied the waters a little bit. So definitely something to keep track of for next year.
I was going to say one thing that would be good is a lot more automation, if at all possible. You know, we should try to write some scripts and have some stuff prepared, if at all possible. I did start trying to write some sort of automation script to basically enumerate all the other teams that actually have services that are up, so that we know who to attack, so that we're not waiting in timeouts and stuff like that. A few other things to kind of handle various exploits. We can just kind of drop them into the script very easily as we write them. I'll continue developing that time, but just figured I'd point that out. I was also wondering about the possibility of like a shared red team server for next year or something like that. So that way we're not like having to go into Dradis, copy stuff out. We can just literally just move into the other directory, see the script, move from there. Just a thought.
Yeah, I mean, the beauty of virtualization is we can have multiple servers. So if there's a red team server stack that we want to run, we can definitely do that.
Well, I think that the idea was that there would be a server for red team to receive information specifically from blue team or ops or whatever regarding intelligence objectives, whatever.
Sure.
So
like here's the task to work on, or here's the intel coming in.
Yeah.
Makes sense.
Or if it's possible. Go ahead.
Oh, in the communication part, I did have some confusion as to, where some information should go, or, where the information is located. In terms of, should this go to blue team, should this go to red team, should this go to both, or, is this information in red team's folder or blue team's folder? There might be a better way next year. Just kind of be thinking out loud that we can organize the information, maybe in terms of possible vulnerabilities, possible exploits, that kind of thing.
Yeah, I would agree. That's another one where the best laid plans go astray. My thought initially had been, the people who get there around 9 o'clock will just huddle and I'll set up Dradis and make it pretty. And what I didn't realize is when you change the IP address of the team server, that breaks Dradis. So between that and some dependencies, Z-Tango hopped in and got on it and straightened it out, but by the time it was all straightened out, it was like, game time, and we never really got to a point where we could set up a good structure. So I definitely agree that's something that I need to, on the team captain side, get done well in advance, and probably even put it in the quick start guide. But actually, this sounds like we're starting to head into the lessons learned. So are you guys good with me advancing to lessons learned at this point?
Sure.
So I took what I thought were some common themes, and I threw them up here to share with people, and then I've got an open mic at the end of that, so that if there's anything that you guys feels pertinent that I missed or whatnot, obviously I couldn't put everything in, but I think I got the main things. A couple of the main things was getting some breathing room. The war room was a bit cramped and a bit warm and not necessarily organized. I know we touched on it in the blue and the red section, but next year we're talking about online tech bringing us back. Thank you guys. But being in the bigger workroom and rearranging the tables such that it's a little bit more conducive, a little bit cooler, and more suited for our workflow. Sharing the load, as mentioned earlier, we had a lot of people in blue, and there was some question as to what should have been blue, what should have been ops. So one of the things we may look at next year is signups will continue to be what they are. Hey, everyone pitch in where you want. But as we get closer to the team or the day of, we may have some discussions of, hey, we're pretty heavy here, we're pretty light there. Can we rework things? Or can, if we've got some downtime, can blue help ops out, setting certain things up, etc. Sharing is caring. The plan was this year to limit vol to ops, right? This is a traditional ops mindset, which is the few people have root, the fewer people are making changes, the more stable an environment is. Perfectly legitimate in 99.99% of the cases. However, in relation to a CTF, you need to have the vol image with the actual flags to be testing on attacks, to try automation scripts, to work through the code, to do the forensics, etc. So we've got to find a way to make sure that people can get on the server. And what happened this year is everyone was like, hey, I want to try and do something. Everyone got on vol, and that created some confusion. So we're going to look between now and next year at different options, be that our syncing to a backup server, being it using VirtualBox and taking a snapshot and mounting it somewhere. I mean, there's a gazillion ways to slice and dice. It's just about figuring out what's the easiest way to do it.
Actually, on that topic, I was giving that a little thought
sure.
over the past
and
week.
Who's this?
Oh, this is 357.
Ah, okay.
What I was thinking was that, we bring it up on the Vuln server. We bring up the Vuln VM on one box, and then we have another host machine where we bring up another Vuln. And then what we do is that if we did an rsync from the main Vuln to the backup, it should remain, it shouldn't do anything since it's a Delta copy. But then we set a cron job to run, say, every minute or so to rsync over to the backup. Or, we can set it to whatever, you want. But the point is, instead of rsyncing the entire thing completely over, which could take upwards of 2 hours, we do 2 installations, and then we do an initial rsync to just make sure everything's okay, and then we set up a cron job to rsync every X amount of time, and that should alleviate all the concerns. And then we just set up IP tables rules so that rsync only works between those 2 boxes.
Yeah, perfect. Perfect. What we have here is a failure to communicate. As I already talked about, we need to figure out the best way to use IRC and DRADIS. Worlds of improvement over last year, still some room to go. A couple of things, feedback that I got from people was funneling more communication to the squad leaders because they've got a good feel on what's going on. And having the squad leader update IRC is appropriate, maybe through a squad leader's IRC channel. The IRC channel was great, but there was some confusion over what was actionable announcements versus what was, conversation. So making that a little bit clearer to have a channel for announcements versus a channel for each squad. And beefing up the hardware for the team server. The DRADIS install, and I'm still troubleshooting this, I put it on really fast hardware, like my enterprise-grade hardware, and it was still slow. So there's something wrong with DRADIS or the way I'm deploying it, but between how it was...
That Linux image had something going wrong with it, Wolf. Because it was crashing as soon as you... Because when I was trying to fix it in the morning, you did something to the network stack, and it just bombed the entire image.
Yeah.
So there's something up with that. I don't think it's so much DRADIS as it was. There's something up with that Linux build in that VM.
I agree, and I think the bottom line is, for the team server to be effective, the team server has to be quick. Just like anything else, if it's a tool that slows you down while you're using it, you're not going to use it. And we ran into a lot of that with the team server. And getting to the Zen of things. This is a quote from Zen Mode. and I liked it, so I put it in here. What we need is tool set and training prep, service and image analysis processing, hardening, monitoring processes, exploitation, weaponization theory, automation, scaling, and more theory. So we've got an entire year to tighten up. Some of the things that are on the roadmap in January, we're going to be doing a code analysis with IDA Pro and some other tools workshop in January. We're looking at doing a security onion for Blue, one of those workshops mid-year, hopefully trying to bring in Doug Burks. And we're also going to look at a CTF prep workshop where we build the environment from, scratch all the way to hosting the images and doing enumerations on them in October. So we've got some things going on. I am very interested to figure out good ways to look at weaponization theory. So if anyone has ideas about that, obviously share them. But we've got, the standard misec ability to do meetings, to do workshops, etc. So we're going to be tightening up all the time. With that, open mic. Is there any lessons learned that I didn't cover that you guys want to share? Silence. Good. That means I summarized it well. Yay. All right. I'm going to move on. If anyone thinks of anything, you may, of course, jump in. We're just about at the end of the call. So, actually, we are at the end of the call. That is the end of the call, ladies and gentlemen. That is
Yay.
the Russian CTF in English. Woohoo! So, again, I want to thank everyone for taking part. E for extended, yes, extended by an hour and a half. 90 minutes of free CTFing. It's like 10% free.
Well, no, but I meant that we weren't Russian academic participants.
Oh. That'll work too.
Yeah, we do an RuCTF without the E, and that's just for Russian universities.
Hey, Wolf,
Gotcha.
I did have one thing.
Yes.
This is Zen. So kind of touching back on some of the documentation concerns and general communication, maybe it would be a good idea to perhaps instead of that October event, talk about what our standard documentation is going to look like and what each squad's documentation is going to look like so that we know what points are actionable and how to communicate them.
Yes. Good idea. So as part of the Linux for CTF's workshop, discuss ideal ways of setting up communications.
Mm-hmm.
Patterns and practices. Absolutely.
Maybe also go over, what to expect, some, touch on points that, we talked on here and, go over what you're going to see, what you can, what you should be expecting anyway.
Mm-hmm. And how to prepare, how to plan.
Yeah.
Sounds good. We'll do it. And D. Tom, what is the next CTF coming up?
Well, last year, probably RuCTF, we did the Ghost in the Shell code. So if they're offering that publicly, then I think that's for sure one that we will work on. But I mean, if anyone else sees any comment or hears about it, let us know. And also, I want to say that everyone's free to kind of captain a team if they hear about some. Jeremy kind of captains the Poly CTF. Wolf does the RuCTF. So, if you want to really just kind of stick your neck out there, feel free. So, I would say Gits.
Gits it is. Yeah, and definitely this is, if anyone sees a CTF or event that they want to throw together and pull a team in, like you said, do it. It's fun.
Well, what about, do we want to mention the other ones we're working on?
The one that the Chicago-Detroit?
Yeah, that one.
Yeah, I think we could give a spoiler here. I think we've got two of the main people, right? We've got Chicago on the line. We've got Detroit on the line.
True. So
what do you think? Go ahead.
That might be one of the next ones coming up too, because we're working on combined B-sides, Chicago and Detroit BTF. It'll span both the events. So I think that'll be pretty sweet, and it's going to start when B-side Chicago comes online. So that may be one of the ones coming up too, within 4 months.
Yeah, so, buddy, it's going to be fun.
Yeah, so be ready. You've been warned.
Be ever vigilant. You've been warned. All right, guys. Thanks a lot for taking the time tonight and for all the planning, the prep. We had a lot of calls, had a lot of fun. So I really appreciate it. It's been a lot of fun learning with you guys. So with that, I will stop the recording. Good night, misec.